Hi, questions in analysis in this textbook. Question 1. Let f be a continuous function on the semi-closed interval 0 infinity. Show that if f is uniformly continuous on the closed interval a infinity for some positive real number a, then f is uniformly continuous on the closed interval 0 infinity. Solution. Suppose that f is uniformly continuous on the semi-closed interval a infinity for some positive real number a. Since f is continuous on the semi-closed interval 0 infinity, f is continuous on the closed interval 0 a plus 1. Since this closed interval is compact, f is uniformly continuous on this closed interval. So, for any positive real number epsilon, there is a positive real number delta 2 such that for all xy in this closed interval, if the absolute value x minus y is less than delta 2, then the absolute value of fx minus fy is less than epsilon. Since f is uniformly continuous on the semi-closed interval a infinity, for any positive number epsilon, there is a positive number delta 1 such that for all xy in this semi-closed interval a infinity, if the absolute value x minus y is less than delta 1, then the absolute value fx minus fy is less than epsilon. We see that if x is in the closed interval 0a, y is in the semi-closed interval a infinity, and the absolute value x minus y is less than 1, then x and y are in the closed interval 0 a plus 1. Similarly, if x is in the semi-closed interval a infinity, y is in the closed interval 0a, and the absolute value x minus y is less than 1, then x, y are in the closed interval 0 a plus 1. We also see that for real numbers x, y such that the absolute value x minus y is less than 1, if x is in the closed interval 0 a plus 1 and y is in the semi-closed interval a plus 1 infinity, or x is in the semi-closed interval a plus 1 infinity, and y is in the closed interval 0 a plus 1, then x, y are in the semi-closed interval a infinity. We thus conclude for any positive number epsilon, there is a positive number delta given by the minimum of 1, delta 1, delta 2, such that for all xy in the semi-closed interval 0 infinity, if the absolute value x minus y is less than delta, then the absolute value fx minus fy is less than epsilon. This implies f is uniformly continuous on the semi-closed interval 0 infinity. Question 2. Show that fx equals square root x is uniformly continuous on the closed interval 1 infinity. By the previous question, This function is uniformly continuous on the closed interval 0 infinity. Solution. Consider this function. Let epsilon be a positive real number. For any real number xy in the semi-closed interval 1 infinity, we have this inequality. Take data equal to epsilon. For all xy in the semi-closed interval 1 infinity, if the absolute value x minus y is less than delta, then the absolute value fx minus fy is less than epsilon. This implies f is uniformly continuous on the semi-closed interval 1 infinity. But question 1, f is uniformly continuous on the semi-closed interval 0 infinity. Question 3. Let f be a function on the domain D. If there is a constant k greater than 0, such that the absolute value fx minus fy is equal to or less than k times the absolute value x minus y for all xy in the domain D, we see that f satisfies a Lipschitz condition. Show that every function f satisfying a Lipschitz condition is uniformly continuous. Solution. Suppose that the function f satisfies a Lipschitz condition. Let the epsilon be a positive number. Take delta equal to epsilon over k. For any xy in the domain D, if the absolute value x minus y is less than delta, then the absolute value fx minus fy is less than epsilon. This implies f is uniformly continuous on the domain D. Thanks for watching. Bye.